Good afternoon, ladies and gentlemen. This is Miriam Sharif, a research assistant at the Sharjah Academy for Astronomy, Space Sciences and Technology. And today I will be presenting about the UAE Meteor Monitoring Network, one of the Meteorite Center units at our academy. The center contains three different units. The UAEMMN is one of the units, as well as we have the machine learning unit, and we have the meteorite analysis unit at the Meteorite Center. But today we will be talking about the UAE Meteor Monitoring Network. And just before we start talking about the network, it is really important to know the differences between some of these celestial bodies, the comets, asteroid, meteoroid, meteor, and meteorite. So the main difference between comets and asteroids is that comets are icy bodies, while the asteroids are rocky bodies. So once the parts of the or small chunks of the asteroid or a comet separated from the parent body, and it's called as meteoroid. And once the meteoroid enters the Earth atmosphere, it's called meteor. So the streak of light of this the space rocky body is called a meteor once it enters the Earth atmosphere. And once it lands on Earth, it's called a meteorite. Okay, so the picture at the bottom, it shows the three different as you can see now, this is the meteoroid, and now once it enters the atmosphere, it's called a meteor. Once it lands, it is a meteorite. And the UAEMMN project focuses on observing and detecting out these meteors, the one that enters the Earth atmosphere. Okay, so the UAE Meteor Monitoring Network is a project funded by the UAE Space Agency and operated by the Sharjah Academy for Astronomy, Space Sciences and Technology. The network consists of three identical towers in three different locations. The first tower is located in Sharjah, specifically at our academy, and the second one in Al Yahar, which is in Al Ain area, and the third one is in Liwa. The three towers are automatically used to record from sunset to sunrise on a daily basis. And each tower consists of 17 cameras, which we'll share the details later on. So here you can see the towers' locations on the map, as you can see on the left. So the first one in Sharjah, the second one in Al Yahar, and third one in Liwa. These three locations were selected based on a coverage simulation, as you can see the picture on the right, to make sure that we cover almost the full UAE sky. But still we have some gaps at the western part of the country, and that we are planning to add more towers in order to cover out these missed areas. So for the tower structure, as you can see an example of one of the towers on the left, it consists of three levels. The first level contains the PC and the monitor, where we can control the cameras. And the second level, you can find an empty space for storage, or you can just walk by to the upper level, where you can find all the cameras. As you can see, the picture on the right, it's the camera representation. This is a top view of the tower. You can see the cameras are set on a ring-like structure distributed all over the ring, as you can see. So the cameras that are on the outer ring are a combination between 6 and 8 millimeter wide lens camera, and at the middle here we have an all sky camera to make sure to cover the whole sky. Okay, so moving on camera details, as I mentioned that there are three different lenses. The 2 millimeter is for the wide sky camera, and 6 and 8 millimeter are distributed all over the ring. Okay, so we're using the CCD Sony camera for this project. Here you can see the distribution of the cameras. We have the 2mm shown in blue, as you can see in the middle. And we have on the outer borders, we have a combination between 6 and 8mm wide lenses of the camera. The red dots represents the 8mm, while the green one represents the 6mm camera. So this specific selection of camera distribution is to make sure uh, to cover almost the full sky, to have a better sky coverage. Okay, more camera details. As you can see here, we have for each camera a specific altitude and azimuth that we set for each tower. And on the right, you can see the sky coverage per cameras. So the red squares represent the 8mm, while the blue one is for 6mm camera. That's for the camera part. Now we remotely connect to the towers that we have, to the 3 towers, as I mentioned earlier. So we remotely connect through 3 different stations at the academy to do the filtering process, because the cameras used to detect and save any movement from any object. So we do filter to make sure that we have only Meteor files, and then we store it in the cloud. Okay, so here you have the network timeline. So as you can see, the 3 towers were not installed at the same time. However, we have, for example, the first tower was installed on 5th of September 2018, which was in Sharjah location, and then we had Liwa station on the 27th of September 2018. That's for 2018. In early 2019, we had the 3rd tower in Al Yahar joined the network. So we have different timeline for each tower. And here you can see the network statistics that from September 2018 till like almost September 2020, we have almost completed 2 years of observations, meteor observations, of course. So as you can see, the graph represents the quantity of meteors that have been observed in each day, in every for every month by the 3 towers. The blue line indicates for Sharjah, and the green line for Al-Yahar, and the brown for Liwa. And as you can see, here we have for the 2018 period, and here all the year of 2019, and for 2020, we have till September, till the 22nd of September. This is the latest updated data that we have, which was till yesterday, of our meteor observation. So in total, we have observed 24,007 meteors. Between these, there were 2,876 double detection and 260 triple detection. What we mean by double and triple detection is that the same for the double detection is that the same meteor was observed by 2 towers, while for the triple detection is the same meteor have been observed by the 3 towers. So the double and triple detections are really important and essential for further meteor analysis that we'll be sharing later on this presentation. Okay, so what you can see here from this graph, there are some trends. So the number of meteor observed, uh, it is variable depending on the month, because if we have a meteor activity, then we will have a high meteor detection, other than other months that we have low meteor activity. And there are several factors that affect the our meteor observation. For example, the weather conditions has a major impact on our observation. So if the weather was cloudy or foggy, so it will be hard for us to observe the meteors, which will result in less number of meteor observed uh, per month. Also, the tower location play a major role in showing the have to show number of meteor observed. And for example, we have in Sharjah Tower, which is in a city, so it's affected by the light pollution around the area. So we have, as you can see, the blue represents the Sharjah Tower, which shows always the minimum value compared to other towers, because the other two towers are located um, in um, in deserted areas, so away from light pollution, and which results in higher meteor observation. So that's for our meteor statistics, as you can see. And yes, for example, as you can see, there is a peak on December 2018, and this is because of Gemini's meteor shower, which it's well known with its faint but a high rate of meteor per hour. But if we compare December 2018 with December 2019, we see there is a difference between these two values. And the reason behind this is because of the moon phase. So even the moon phase affects our meteor observation. And I will show you in the next slide. So we have compared Sharjah 2018 with 2019 observations during the December period, which is for Gemini's meteor shower. We took the peak days of the shower, which is the 14th and 15th, and we have compared it, and we have seen that about 67% of meteor observations they were decreased. So less meteor observation. The light blue is showing the 2018 values, while the dark blue is for 2019. As you can see, there is a huge difference, and that's because of the moon phase, which was in 2019 a full moon during the peak period. Okay, so here we have more meteor counts details. The one on the left is for 2018, and the one on the right for 2019. Uh, these tables represents per month. We have the meteor showers, the major meteor showers that occurs during this month. And if we have a full moon in which specific dates, the number of cloudy nights, which affects a lot on our meteor observation results. And we have the quantity of meteor observed per tower, because in 2019 we had only two towers in operation, which is Sharjah and Liwa. So we don't have Al Yahar here, but in 2019, yes, we have Sharjah and Al Yahar and Liwa, and they are and here we are showing the major showers and the full moon in which date it was, as well as the cloudy nights per month. Okay. So moving on examples of captured meteors by the network. Okay, so we have some interesting examples. Okay, so here we have a stacked image of multiple meteors that were observed by Liwa Tower. This is for a full month of May 2019 for one specific camera. This is an interesting image, as you can see. Here we have an example of a meteor. We call it in the daylight because it was around 5:30 a.m. in the morning. So even though we have like the sun lights appears, still we can see the meteor here, which means that it was somehow a bright meteor. Okay. Here we have an example of a bright meteor. What an interesting in a nice video to see. It's really satisfying seeing out these bright meteors. And we have more examples of bright meteors. This is another one. And here we have also another bright meteor, which we are lucky to have these being observed by our system. Now we have a double and triple detection, as I have mentioned earlier. These are really essential and important for further meteor analysis. So the first two uh, uh, videos are for the double detection, while this one is for triple detection by 3 towers. So this is the same meteor, but this is from one of the towers and this is from the other tower. And here we have the same meteor from the 3 different towers, as you can see here. Okay, so this is Sharjah because, as you can see, the light pollution affected the area. It's a bit bright, other than the two rest of the videos. Okay, and here we have an example of a double meteor. What we mean by double meteor is that we have 2 meteors appears at the same video and at the same frame. We were lucky to have such an event captured because it's somehow a rare event to happen. Okay, and we have also captured a lot of fireballs. This is one of the example of fireball that have been captured by 2 towers, the Al Yahar and Liwa. So it's these 2 images are for the same meteor, but from different towers. And this one from the same tower, but 2 cameras. So this is the other camera. This is one of the cameras, and this is the other one, which completes the full meteor trail, as you can see on this image. We do also capture other objects, you can say, other than meteors from our network. As you can see here, we were able to capture one of the satellites, which is a Milstar satellite. I will show you the video on the right. It's a very tiny object, as you can see on the video. But how we can differentiate between satellite and a meteor? So as you can see for the satellite, it's like a one small dot with 2 tails. So that's how we can say that this is a satellite, other than the meteors are just like a long line with somehow a dot by the end. Okay. And also, early this month, we were able to detect some rocket boosters. We believe that it was for the Astra rocket 3.1. And here you can see the video on the right. It is relatively slow compared to meteors. So that's why we noticed that it's not a meteor. However, it's a rocket boosters that appears in the video. Right, so that's for some examples of captured meteors as well as satellites and rocket boosters from our network. So now we'll move on the software that are used for this specific project. We have 3 softwares. We have the UFO capture, UFO analyzer, and UFO orbit. For the UFO capture is used for capturing the meteors, which is linked to the cameras and connected to the cameras. Once we capture a meteor, it provides us with 4 different files. We have an AVI file, which is a video, an XML, and 2 different formats of images, the BMP and JPG. These files we use them as an input to the UFO analyzer, which is the second software that is used. And then we use to analyze out these files to produce another file, an MCSV file, to input it to the UFO orbit, which we can get the finalized analysis results. So starting with the UFO capture, this is how the UFO capture window looks like. we have different sheets, input, operation profile, and DB sheet, where we can set out some parameters and some specifications. We set the recording time that used to automatically records the meter, so we don't need every time to uh, reactivate the camera. So the cameras automatically records from sunset to sunrise, as I said, during the nighttime. So that's what we used to do. And we also do, we can reactivate the cameras and we select the cameras all from out this specific software. And then we have the UFO analyzer. As you can see, we have also different sheets. The main sheet where you can input the files that you want to analyze, and then you can specify the cameras and the camera specifications in the profile analyze, and then you can analyze all the file, and we produce the CSV file that we use it as an input to the UFO orbit software. As you can see here, we have three different sheets: the main, quality, and stream. In the main sheet, you just select the file that you want to continue in analyzing, and then you can either check for single station, pair, or unified. But for the single station, the one and only result that you can get from these different maps is the trail map. If you want the results from other maps, it has to be either paired or unified radiant operation mode. So that's for the main sheet, where you can just set all of the files that you want to analyze. So then we have the quality sheet. We have three different quality levels from Q0 to Q3. Q0 is with the minimum requirements or with the minimum variables restrictions. And once you move on, there are more requirements that are set to make sure that we have uh, the highest quality, which will eliminate the bad meteor observation, or the the not really accurate and correct meteor observation. So that's for the quality sheet. Moving on, the stream sheet, where we can see the meteor streams, as you can see here, with the quantity per meteor stream or meteor group. So for example, here we have a sporadic meteor, which was about, during this specific analysis, around 112 meteors. And also we have in Perseus, the Eta Eridanus meteor shower, and Capricornus, um, Alpha Capricornus meteor shower. So as you can see, here are some radiant points for each specific meteor group that is mentioned here. And we have four different maps as a result from the UFO orbit. The first one is the radiant map, as you can see here, which shows the radiant point of each meteor observed and during the specific analysis. As you can see, we have like different colors, and the colors are varied based on the meteor velocity. As you can see here, the meteor indication velocity, the color indication. And we have several, as I said, meteor groups, as you can see in the circles. Okay, so some of the meteors are within these meteor groups, and others are spread all over this map, which are for the sporadic meteors. The sporadic meteor means that this specific meteor, it doesn't belong to any meteor group. So that's for the sporadic meteor. Moving on, the trail map, which shows the trail of the meteor over the star map. Okay, so as you can see here, all of these meteors are appearing from the same point, as if they um, are appearing and resulting from the same point, and that's for the Capricornus meteor shower. And here we have the ground map, which shows the trail of the meteor over the the map of the Earth map. Okay, so the trail map was to show the trail over the star map, while here we have the trail of the meteor over the ground map. And what you can see here, it's not the the predicted landing location. No, it's just where this specific tower have been observed, that specific meteors. So if this meteor was big enough to land on Earth, then we can do some calculations to identify the possible landing location, which can be like a wide range area that uh, for other to go and search for that specific meteor within that uh, area. But that's a really hard job. That's why we have the machine learning team that they are developing some algorithms to attach with the drone in order to find out these meteors on the ground. And finally, we have the orbit map. As you can see here, uh, the yellow dot is representing the sun, and the blue dot is representing Earth. So this is the sun, and the blue orbits are for the other planets' orbits. And here we have the orbit of the Earth, and the yellow circles are for the meteor orbits. So as you can see, all of these yellow circles are at the end attaching to the Earth. That's where the meteor have been entered the Earth atmosphere and fall on the Earth. So that's for the orbit map. Now for meteor analysis, we either analyze for a specific meteor or a specific fireball, or we can just analyze for a certain period. So we have two examples here for one of the fireballs that I have showed you earlier on the 1st of August. I will show you the analysis of the specific fireball, and then I'll show you the analysis results of this specific period. So now here we have the ground map and the orbit map of that specific meteor. That's where the two towers observed the meteor. As you can see here, it was closer to Liwa, and this is Al-Yahr. So that's the ground map, and the orbit map, it shows that this is the orbit of that specific fireball or meteor. And it appeared that it was a sporadic meteor. It doesn't follow any meteor group. And now we have the period analysis. We have selected this period because there are a multiple of meteor showers that happen to appear in this period from the 17th of July till the 23rd of August. These are the analysis. After the analysis, we have found that 25 of the meteors were sporadic meteors, and 9 Capricornates, and 4 were for Perseids meteor shower. And as you can see here, this is the radiant map. These are the meteor groups for the Alpha Capricornates and the Perseids, and some of the meteors are here are for the sporadic meteor. That's for the radiant map, and now we move on the trail map. So these are again for the same period. The trail for each meteor group. This is in this picture we have the sporadic analysis, and here we have the Alpha Capricornates, and here we have for the Perseids. And here we have the same, the ground map for these 3 meteor groups for that specific period, as you can see. And we have the orbit map for the same period as along with the same meteor groups. As you can see here. So these are interesting results that we were able to analyze and figure out. from our meteor observation, as you can see. So about the publications, we have several publications in different areas. We have in journal articles as well as magazines and conference proceedings and in astrophysics data systems. So in regarding the journal articles, we have published in June 2020 in Journal of Instrumentation, and we have two articles published in two different magazines, the Rome Space Magazine and Emery Magazine. And we have an international meteor conference we have published in February 2020, as well as in Meteor News that we have also some uh, publications. Okay, so now of course you can be part and contribute to this network. So if you saw a meteor, then you can share out some details. You can just visit out our website at sast.ae under the I saw a meteor. You can just enter your name, you provide us with your email and contact number, and you provide us from where, which location you were, and the date and time. And if you have, you were lucky to capture and to take a picture of that specific meteor. It's great to attach it along with this submission. And by that, we will be having eyes like we have eyes everywhere to capture and to see out these meteors and to have better analysis results as well as to benefit everyone regarding the meteor that have been observed from the UAE. So that's for today's lecture. I hope you have enjoyed it and learned from this lecture. And I would like to thank you for your time and thank you for listening. And if you have any questions, I am more than happy to answer out your questions.
Thank you very much, Mariam. I appreciate that. Thank you. Please, the audience, if you have any questions, you can ask Mariam. Any comment?
Seems that there are no questions.
They're all shy. Okay, thank you again, Mariam, for this good lecture, and hopefully so everyone has been updated about what you are doing. So thank you very much again.
السلام عليكم دكتور الياس.
وعليكم السلام. Please
الله يبارك
محمد.
فيك. We are not shy. شكرا كثير على الله يبارك فيك يا اخت مريم، والله يعني very instructive هذه المحاضرة. أنا أول مرة بعرف يعني first time I know all that. Thank you very much really. يعني فيها أشياء informative، ونحن we get an idea, a good idea about what there is around us يعني. Just we are here in the planetarium and in the exhibit, and now we know what we can see outside, what we can see really inside this devices, and very huge devices, and really it was very important what you say. And thank you, Dr. Elias, also to give us this occasion to know about that. Thank you, Mariam.
You're welcome.
I don't have any questions, but at least just I want to thank you, and Dr. Elias also. شكرا دكتور.
Thank you very much. Thank you.
الله يبارك فيك.
Anything else? Okay, thank you very much, Mariam. So thank you very much. So please see you next time for the next lecture, inshallah. Okay, salam.